So moving on with problem 15. Using your own words, can you describe the concept of head loss? So, define. So I'm going to work on the right-hand side here, define each of these terms, and then I'm going to describe it and use the formula. All right. So HF is, the meaning of this term is head loss. It's measured in feet. L is the equivalent pipe length, also in feet. Q is flow rate in gallons per minute. C is Hazen-Williams constant. That's from a table. And then D is pipe diameter measured in inches. All right. So the concept of head loss, H sub F, is the amount of energy lost in the water due to friction and turns in the pipe from the source to the destination. And then the formula, not something you need to memorize. You can always just look it up. H sub F is 10.44 times L times Q raised to the power of 1.85. All that divided by C raised to the power of 1.85 times D raised to the power of 4.8655. I believe it. I'll double check that last one. Do I have it somewhere? Not sure. I actually have it open right at the moment. Either way, that's what I believe it is. Let me double check. Yes, 4.8655. Okay, so that's number 15. And number 16, one more example problem. So we're going to go through the whole process: static head, head loss due to friction, dynamic head, and actual pressure. Based on this problem, where the outlet elevation is 825 feet, the discharge elevation is 650. All the fittings are from problem 12. So if I look at problem 12, we have equivalent pipe length of 462.8 feet. So that's the equivalent pipe length. Plus 2.8 miles of length there. So I need to make sure to put that in there. Equivalent length is equal to 4. Let me just double check. 462.8. Just so I don't have to go back there. 62.8 feet. Flow rate Q of 115. 10-inch cast iron. So if cast iron, then C is 100. That's what coming from that table. All right, so let's go through this process. So static head is equal to source elevation minus distribution elevation is 825 feet minus 650 feet. And therefore you get 175 feet of static head. All right. Head loss. Oops. Let's see. H sub F is equal to, we have, that's Hazen-Williams 10.44 times L. So we need to figure out what L is. L was 462.8 feet. That's for the fittings, plus 2.8 miles times 5,280 feet per mile. So you get a total equivalent length of 14,700. Sorry. Let's double check that. So we have 462.8 plus 14,784, which means L is a total of 15,246.8 feet. So that's what goes in right here. 15,246.8 times the flow rate. So that's 115 raised to the power of 1.85. All that divided by 100 raised to the power of 1.85. And then the pipe diameter D was 10. So 10 raised to the power of 4.8655. Remember, when you type this into your calculator, I'm using a screencast where you don't see I can't show you my calculator right now, so I want to make sure I just show you this because this is where you do need to be very careful. So think of everything in the numerator divided by everything in the denominator, but the denominator you need to be careful. So you're going to type in 10.44 times 15,246.8 times 115 with a caret of 1.85. And then here, end parenthesis, divide, open parenthesis, open second parenthesis, 100 caret 1.85, close parentheses, times, open a new parenthesis, 10 caret 4.8655, close parenthesis, close parenthesis. All right, and if you're careful about that, you should get the head loss is approximately 2.81 feet. All right. So there we have that. C, the dynamic head, is equal to the static head minus the head loss. So remember, it's 175 feet minus 2.81 feet, and you should get 172.19 feet. And then finally, the pressure, the actual pressure, is equal to the dynamic head. Oops. Divided by 2.31, and that's feet per psi, because this is in feet. Feet divided by feet divided by feet, psi in the numerator or denominator moves it to the numerator, and so you get 172.19 feet divided by 2.31 gets you 74.54 psi, which is excellent pressure. It's exactly what you want if you're able to have that. All right, so that's the practice problems. So after this, you're going to take a quiz. My recommendation is if you can do these 16 problems, kind of smaller problems leading up to a full calculation here, you're just fine.